Hello and welcome to our talk on predicting merchant financial well-being using network features. In this study, our aim is to predict future performance of small and medium-sized enterprises. SMEs account for a significant portion of the economic activity in most countries. Their performance is directly associated with their employment rates as well as economic productivity. For example, in the European Union, as of 2019, there were about 25 million SMEs, accounting for 99.8% of all enterprises in non-financial business sector, responsible for about 67% of jobs. Similar statistics hold for the US and China, showing the importance of the SMEs as their performance is directly associated with unemployment and employment rates. So most of the SMEs heavily rely on business financing from banks and lenders to run their businesses. But on the other hand, according to the US Bureau of Labor Statistics, about one third of SMEs fail within their first 2 years, and roughly half of them survive after their first 5 years. So, as a result of noticeable failure rates of SMEs, financial institutions have to carefully assess SMEs to make decisions on business loans. On the other hand, as the number and diversity of SMEs keeps increasing, it becomes more costly and difficult for financial institutes to assess individual SMEs by subjective judgment. So for them, an accurate model that can predict the financial well-being of the SMEs in future is crucial and will improve their decision making and help reduce financial losses. In the literature, there are such studies defined as likelihood of defaulting on a loan or bankruptcy probability. These studies mostly rely on financial metrics like earnings per asset and equity per asset as input of the models. Most of these studies use machine learning techniques to predict the future performance of the SMEs or corporations. However, these metrics are often difficult to obtain because sometimes there are companies they don't publish those metrics because they are confident, and these even after getting those metrics, they they have limited predictive performance. But on the other hand, existing studies have shown that it is possible to use credit card information to replace this kind of metrics. So, also, studies show that social networks form the backbone of social and economic life, and many studies have shown that the structure of social networks between individuals and communities have been extremely predictive of their wealth. So the question is it possible to define such networks for merchants so we can use the information from that network to predict the financial performance of the merchants? So the data sets we use are two data sets from two banks, including credit card transactions. The first data set includes 3 months of credit card transactions for 1,200 merchants. And in the second data set, we have 1 year of transactions for 4,300 merchants. So here, we define the merchant's financial well-being based on its revenue improvement rate. Specifically, we split the credit card transactions into two periods, like first half and the second half. And then we calculate the revenue improvement based on the average monthly revenue of the first and second periods. Then we convert the improvement rates into binary label based on the median value. So if the rate falls above the median value, we transform it into 1, and then if it is below the median value, we transform it into 0 as a binary label. The features we extract from the dataset includes customer features, which are related to their demographic information, and also as the revenue-based features, we look at the transactions from the credit card data and calculate monthly revenue, number of transactions, number of unique customers, and statistics of monthly revenues, as well as business category code for each merchant. So these are two first single data sets we calculate and extract from the uh, credit card transaction data. So now we ask this question, is it possible to create a social network for merchants? We use the customers as bridges between merchants. So we create a network which is a weighted network of merchants based on customer intersection. So if a customer uh, makes purchases in two merchants, actually the customer creates an edge between them, and the number of customers contribute to the weight of the edge. So as a result, we have a weighted, non-directed network for the merchants. So the features we extract from the network structure we have are network features. The first four are general centrality metrics, degree, eigenvector, closeness, and betweenness centrality. And we also calculate the diversity of the category of ego network and also the geographical diversity of ego network connections. Using the various machine learning methods, we get the best results by using gradient boosted trees. This is the best performing classifier for our both data sets. So in both data sets, we show that among all the single feature sets, network-based features perform the best. And then the combined feature sets is not actually much better performing than only network features. So to conclude, the results indicate that the network features capture the financial well-being of merchants better than the other single feature sets. The type of network we propose can be generated by aggregating anonymous credit card transactions. That means that the analogy to origin destination matrices for customers between merchants can be very effective for planning and managing stores, and that everyone can get access to that and use it. So finally, we conclude that as we live in a social network, merchants run their businesses in a social network as well. Thank you for your attention.